Hello and welcome to this GitLab Admin Fundamentals. This time it's about system administration. Today I would like to walk you through a few topics. That's the GitLab architecture, a bit of a recap and a bit of a new information. Then some information about backup, logging, storage, feature flags, and some of the CLI tools that we have. Let's dive into the architecture first. So what was GitLab's architecture looking like again? This is how a typical basic architecture looks like. We have the load balancer where all the traffic comes in from the client. Then we have our GitLab Rails server running on Puma and GitLab Shell where all the web requests come in. Any jobs that have been created in the background, for example, for long-running jobs, will land into Sidekick. Sidekick is our job processing tool, and they might interact with Elasticsearch, object storage, Git.ly, Redis, or Postgres. PostgreSQL is our database, which might be replicated or not. Then we have Redis for caching and queuing. And Git.ly is where our Git repositories are stored. The object storage, I'll come to that later, but that's containing all other kinds of artifacts in there. And next to these objects, we also have this service discovery tool and Prometheus. Grafana is a tool that you can install indeed as an extra, but you have to do that manually. With GitLab Omnibus, you have all these components in one instance, but we have many more ways to deploy GitLab. Of course, you can deploy GitLab through Docker Kubernetes, but you can also deploy on Google Cloud and Amazon Web Services through the marketplace. We have Terraform scripts. We support different Linux distributions, and of course we also have our GitLab.com offering. As I said, GitLab Omnibus is sort of a single package, easy to install GitLab version. It comes with all the basic package distributions like apt-get and RPM and so on. You can run simply the RPM installer to install GitLab, and it will automatically install all the packages and all the components on your instance to run GitLab in. I have this Omnibus installation running, and I will show you later how that looks like. As I said, how you can install it. So you do an apt-get in this case for a Ubuntu or Debian installation. You install certain packages, and then you will install GitLab. In this case, for example, the Enterprise Edition. Next to this Omnibus installation, we also support reference architectures up to 50,000 users. You can imagine if you run an instance with 50,000 users, that a single instance with all components running on the same machine is not efficient and effective anymore. At that time, you need to scale. You need to scale both horizontally and vertically, going from a single node to multiple nodes, separate nodes for database, separate nodes for Redis, etc. And also scaling horizontally with different nodes, for example, in an application cluster or in a Redis cluster. We also support cloud native, so we support installations on Kubernetes, but it's a cloud native hybrid support because not every single component is suitable to run in a Docker container or in a Kubernetes cluster. These components specifically are the stateful components like the database, Redis, and Git.ly. For these three components, for the database and Redis, it's easy to use, for example, the AWS or Google Azure services that are available. For Git.ly, you still need to set up a different environment. To support you even better with that, we have developed the GitLab Environment Toolkit. This is an easy to use suite of scripts based on Terraform and Ansible to help you set this up. For really advanced configurations, we can also set up, also with the GitLab Environment Toolkit, geo instances for geo replication, for example, for disaster recovery or for availability in an offline geographic location. Now, how does a large installation look like? I took the 50,000 user reference architecture. The 25,000 user will look similar. So when your architecture scales, it's basically scaling the different clusters with more nodes, rather than that the architecture is looking a lot different than this one. So here you see, for example, a Redis cluster with Redis cache and Redis persistent being separated components. Gitly cluster is using Prefect as this cluster administration and orchestration tool, which has a separate PostgreSQL database, and then Gitly nodes underneath. Also, the database uses PG Bouncer to cluster the database in primary and secondary nodes. Here you have an internal load balancer and an external load balancer. And then you have Gitly Rails, the Puma server, which also is a application cluster with multiple nodes. Same goes for Sidekick and Consul. Object storage, I'll come to that later again, but that's using existing scalable object storage solutions that come, for example, with Amazon, Google, or Azure. Now, which reference architecture should you pick? When picking a reference architecture, it's important to measure the real expected load, the requests per second. Why is that? Now, each reference architecture lists not just the number of users, but also the RPS with which this architecture is tested. We have converted that to a number of users. For example, the 1,000 user reference architecture has a certain RPS. But it's not always the same. So not every customer has that. I have seen customers that have only less than 1,000 users, but have require a reference architecture for more than 25,000 users because of this expected load. It's important to look at that. Then some people have very few users, but very high standards on high availability or zero downtime upgrades. They really demand this high available and zero downtime approach. If you need that, then you also need to upscale a little bit because only the 3000 reference architecture supports these zero downtime upgrades. Then it's important to notice, hey, are you running everything on local machines or on virtual machines, or are you running it on cloud infrastructure with Kubernetes as the basis? Now, again, if you run cloud native, be aware that the database Redis and Gitly are not supported with Kubernetes, so you need to find something else. Also, Kubernetes in itself is a very complex tool. So if you want to use that, be aware that you know how to administrate it and how to run it properly. Otherwise, it will become the bottleneck in itself. And finally, the consideration is, do you want to have geographic features or not? So do you want to have cross-regional distribution where, for example, teams are located on the other side of the earth and they need sort of a local copy for lower latency and better performance? Or, for example, you want to do disaster recovery and failover in different availability zones. Clusters typically don't go over availability zones. They will run with, depending on the latency within the same availability zone on different data centers. So some cloud vendors support that. But there you have to really be aware that the latency between cluster nodes has to be within like 2 to 3 milliseconds. If you can ensure that, then you can indeed create a cluster across multiple zones within the same area. Otherwise, you can't do that. Geo is set up and implemented once to really replicate the data on instance level. So you have 2 instances of GitLab running in different locations. And in the background, data is then synchronized, whereas one primary instance is using all the writes operations, whereas the mirror is then also bringing the read operations. Now, this works very well for geographic relocation, but you can also use it for disaster recovery or failover. Cool, then backup. Every system needs backups. GitLab is not different. If you want to back up GitLab, be aware that you have to back up a few things. The database, of course, all your Git repositories, you don't want to lose those. But also external object storage, container registries, configuration files, and other data like Elasticsearch indexes, Redis data, etc. It's a long list, and some are supported in the backup, but mechanism. But for large instances, you have to really look into your backup strategy. So the simple backup strategy is using our CLI tool. We have this GitLab backup CLI tool that will simply write down all data from the database, from the Git repositories, registries, attachments, etc., into a single file. So it will perform a pg dump that will simply write all the data of the database into a single file, add the repository data, registries, etc., and bundle that in a single archive. Be aware that these backups do not include Mattermost data if you integrate GitLab with Mattermost, any Redis data, and also therefore Sidekick job data. So any jobs that have been triggered by GitLab and are therefore in the Sidekick queue, and you do a backup and a restore, then these jobs will be lost. So be aware of that. Also, external object storage is not included. Configuration files in /etc/GitLab, especially if you modify your GitLab configuration, it's important to back those up. Same goes for TLS keys and certificates. They are not contained in the backup file. Also system files, anything that has been changed on the file system outside of GitLab. And as I said, Elasticsearch indexes. Once you scale and your instance grows, you have to look at your backup strategy. Because once you go beyond certain size, for example, more than 100 gigabytes of database or terabytes of a Git repository data, then running a simple GitLab backup will take way too long. I've seen backups running for 48 hours or longer. And we say that if a backup runs more than 8 hours, it's too long. And also you want to look at what your own recovery point objective is. And if that's less than 8 hours, then you have to look at other options. Within GitLab, we use the database snapshots. For example, AWS RDS has this snapshot functionality, but also Google and Azure have that. So you can use the database service snapshots to create backups of the database. Then you can create incremental backups of your Git repositories separately on a separate Rails node, and use existing backup technology to back up your object storage through, for example, S3 bucket backups. Or you can use rsync on LVM snapshots to sync the data on a disk. So what you see here is typically that snapshots are the best backup strategy for large instances. If you want to copy terabytes of data, it's going to take a while. So therefore, incremental backups and snapshots are your best way forward. Cool. Then having a look at logging. GitLab has a very big log system. We have log files per component, and they are listed in the docs. It goes beyond the scope of this session to go into the details of every one. It's a long list, but basically every component you can override the log level. So they have a default log level set, but you can override it with the GitLab log level variable. And also components are automatically configured with log rotation. So log rotation is set up, but you can configure it the way you like on it. For example, if you want to retain log files for a certain period of time or so on. Then we have this GitLab SOS tool, which is an easy way to collect log files for GitLab support. Especially if you're on an omnibus environment, then this GitLab SOS will simply pull all the data from the system, from all the components, and package that in a single zip file. But also for larger scale setups, this GitLab SOS tool can collect log files from all components. Your log files are there in case of emergency. So if you want to troubleshoot a problem within GitLab, then that's the time when you look into log files. Now, looking into individual log files is quite cumbersome. It's not easy, and there's a lot of data in there. So our recommendation is to aggregate these log files in a tool like, for example, Grafana Loki. We have support for Prometheus and Grafana in GitLab. Grafana dashboards are also available to get started. And then you can use in these log entries, you can use the correlation ID, which is a field in many of the log files, not in all, but in many. And that correlation ID can be used to link log entries together so that you can build up sort of a path through the application. Then looking at storage. Storage is a big component in GitLab and can grow quite large. Storage consists of multiple tools. First of all, we have the Git repository storage. Git repositories are stored in Gitly. Gitly is the component that manages all the Git repositories and Git storage. With Gitly and Git, you want to store the data on a local file system and not on NFS. NFS is specifically not supported. The reason being that Git repository storage requires fast storage system. If you have a Git operation, Git typically has a lot of small files to write into or to read from, and that requires this fast storage system. So if you run Git and Gitly on other systems than local storage, then you might see problems in performance. So that's not supported. If you want to really scale Gitly, we have Gitly clustering, as I showed you in the architecture. That supports also sharding, where you don't replicate all the data for each node to the other ones, so that you need the number of nodes times the amount of data you have in Git repositories. But you can use sharding to store a Git repository only on one node and then another Git repository on another node. That reduces the amount of storage you need. It's also possible to use logical volume management, LVM, to manage your storage on your disk so that you can grow and expand as you need it, and use LVM snapshots to quickly create a snapshot of your Git repository file system and then use rsync to move it to another system. Apart from Git repositories, you have this large set of other storage data that we need to store. And we have defined object storage for that as a sort of a separate place. Object storage is really separated, and you can keep it simple with a local disk that can use NFS, I must say, but is typically not recommended. But we also support many other storage systems as a backend. With this storage system, you can easily scale it, encrypt it, back it up, etc. We use all these modern available solutions like S3, etc. And you can choose to either consolidate your storage into a single location or separate each and every storage component into a separate location. And these are the object types. So we have secure files, backups, the container registry, Mattermost, the autoscale runner caching, all the caching data for autoscaling runners, but also job artifacts, LFS object. Git LFS is a way to take out large objects that are stored in Git repositories and take them out of the Git repository and store them in a separate storage location. And that storage location is also object storage. Then we have uploads like for avatars, attachments, etc. Merge request diffs. Merge request is typically a GitLab feature, and therefore we store the diff related to that feature on a different storage location. Packages in the package repository and dependency proxy. The dependency proxy is sort of a proxy in front of an external dependency source, and we store these dependencies then within the proxy. Terraform state files. GitLab has Terraform integration where we can manage the Terraform state from within GitLab, but that state file is not stored within your repository but in a separate location. And we have GitLab Pages content. GitLab Pages is a tool to host a static website from within GitLab, and this content is stored also in a separate location. All these object types with a star, those are supported by a consolidated form, so you can store all of these in the same location, whereas these all require its own location. And that can be one of those 6. Oracle Cloud, DigitalOcean, OpenStack can be used for single locations, so to say, but only Amazon, Google, and Microsoft Azure Storage support this consolidated storage format, and with that also encryption on disk and direct uploads. Then have a look at feature flags. So feature flags are used to deploy features in an early stage of development. So if we have an experimental or a beta feature, we can already bring it into the tool, but then disable it through a feature flag so that people can enable it or disable it on their own. This allows us on GitLab.com to incrementally roll out these features. So we roll it out on a single group, or for example, first on our own group and then on customer groups. And for self-managed, it's the same way, but then it's up to the customer to decide whether they want to enable such a feature or not. Be aware though that if it's an experimental feature, it may lead to data corruption, stability problems, performance degradation, and security issues. Depending on the feature flag and the feature, every feature flag is backed up by an issue which describes the feature flag into more detail and also any of the risks that are related to it. Now, if you want to enable a feature flag, you can use the Rails console. The Rails console is one of our CLI tools, and then you can enable or disable a feature, either globally or per project or even per group. There are several scopes linked to the feature. Then looking at the CLI tools, so we have three. We have made more, but these are the three main ones. GitLab Rake, which is like a make-like program to define all kinds of tasks, and these tasks are small scripts that run on the system for all kinds of administrative purposes. Then we have GitLab Rails, which is a direct access to the Ruby on Rails system through a console to run Ruby scripts. These Ruby scripts run directly within Ruby on Rails and therefore are not really protected by anything. If you call an API, it's protected by all kinds of checks and authentication tooling. Ruby on Rails console is not. So be aware that it can even break GitLab if you are not careful. And then we have the GitLab control, which is simply a wrapper around our services that build out GitLab. GitLab comes with all kinds of services and components that are installed, and GitLab control will control these services. Obviously, that doesn't work on Docker and Kubernetes because with Docker and Kubernetes, you typically destroy or stop the container or the pod and then restart it. Have a look at an example. For example, for GitLab Rake, you can show a list of all available tasks, get some information of the environment, do a check of GitLab, clear caches, for example, for Redis, but also look at the database migration. If you do a GitLab upgrade, then the upgrade process will start database migration tasks every upgrade. And with this Rake task, you can check the status of these tasks. And if some tasks are still down and therefore unfinished, you can start these incomplete tasks. Then you have to restart Puma and Sidekick in order to get GitLab up and running again. And another one is, for example, Git FSCK. FSCK is a file system check, which is a very common used Git integrity check. And also that's wrapped behind the GitLab Rake task. An example of how to use the console, as I said, it's sort of a direct access on Ruby on Rails where you can execute Ruby code. So this is command to find a user by name, in this case root user, and then pretty print the attributes of that user. You can also combine these scripts into a single line so that you can use them in an Ansible script or in other scripts to automate, for example, the installation if you want to. Cool. Yeah, then GitLab control, as I said, it's sort of a wrapper around the components that we have. So you can check the status of these components, restart them, but also you can run the reconfigure. GitLab control reconfigure is a very commonly used tool. Whenever you change something in the config file, you don't have to restart GitLab completely. You can do a reconfigure, which will read the config file, checks all the changes in the configuration, and then restarts components as needed. So this is a very interesting tool to use. Cool. Now let's show you a little bit of a demo. I have a GitLab Omnibus installation over here, which runs mostly on root. So I'm going to switch to root for now. And now let's see where GitLab is storing its data. So first go to the configuration. GitLab's configuration is stored in etc. GitLab. As you can see here, so it's the GitLab RB file, which contains all the configuration, and the GitLab secrets JSON. This JSON file contains all the generated secrets during the startup and the installation process. So be sure to back that up, because if you miss it, you can't GitLab won't run anymore. Also, GitLab comes automatically with a root password that is generated on installation and stored in a file here. That file is deleted at some point, and then the root password is only in encrypted form available. So be careful to store that file elsewhere or take the password into a password manager before it's gone. Let's have a look at the GitLab RB file. This is a very long file with all the settings that you can set in GitLab. It's loaded directly into Ruby as a Ruby file. So it's also a kind of Ruby code. You can see, for example, the external URL, a lot of other settings as well. So let's look, for example, for storage, for the object storage. And you see all the object storage configuration items. You see that they are all commented out by default, but this will give you all the default values. So if you want to change a value, then you can change the value, but you have to as well comment it out so it is becoming active. So be aware of that. And here you can see the default path where for example, the artifacts are stored, but also the default path of where the merge request diffs are stored. And you see that that's part of the same directory, so to say, a subdirectory of the same directory. And here you see for the GitLab uploads, the storage path is different. The uploads are stored in a different location, namely in the GitLab embedded service, GitLab Rails. Cool. Now if we go and check out the GitLab logs are stored in /var/log/GitLab. You see that the logs will be stored and divided by components. So for each component you have log files. So the Nginx logs are in here. The access logs, you see that log rotation is in place, so it will rotate logs automatically. If you want to change that, you can reconfigure that, of course. Also for GitLab Rails, you have that here. And I think I can even have a look at it. JSON.log. Here you see how these log entries look like. And if I would grab it on a correlation ID, the one that we mentioned before, then you can see that each entry is linked with a correlation ID. And this ID, it's a GUID style ID. You can use that to correlate log entries in different log files together. Now, as I mentioned also, doing that one by one is quite difficult and cumbersome, so a tool like Loki would be very efficient here. Now then, where is GitLab stored? You have the var/opt/GitLab, that's it, where you see all the components again, and in the shared, you will see that the object storage with all the different object types are stored in this shared directory. For example, in artifacts, you see that they have this kind of hashed way of storing data. It's the same as how Git is storing its refs in its object store. So GitLab is doing the same. It's a kind of file system based database kind of thing. Cool. Then there is also on opt. There's also a GitLab directory, and this is more the GitLab binary. So here you see the CLI tools that we can use, but there's also other tools and other data in here. If you want to control GitLab, we can of course use GitLab control. Here you see all the components running with the process IDs and etc. along with it, how long it's running. You can stop individual components over here or do this GitLab reconfigure. Then we have GitLab wake, all these wake tasks, as you remember, verbose list of all the wake tasks. And you can see which tasks there are. It's a huge list. Here you have it. Now let's run, for example, GitLab wake a GitLab env check. See what it comes up with. And this should give me an overview of different parts of GitLab and the files and the system where it's running on with information. It's not an env check, it's an env info. Now here you see that it's giving me information about the system. It's an Ubuntu version. It's running on the Git user, GitLab 16.10, based on PostgreSQL 14, and so on. So you see all the information in this overview. And finally, we also have the GitLab Rails console. This will start up the console into Ruby on Rails. And through that console, we can set feature flags, but also run some Ruby scripts if you want to, which we have to be quite careful with, of course. But as long as we keep it to read-only scripts, then that should not be a problem. And so let's first show you that thing to get the user attributes. You see it will give me some code completion as well, find by, and I wanted to use username. Let's find it on root. And then it has found a user, stored it in the variable u, so I can pretty print it with all the attributes. And there it is. So these are all the attributes of the root user. The same goes for feature. We can show all of them, but also here we can do a sort of a pretty print through the map function. We can give it a function with an f for all the features, and then an array where we say, okay, we want to show the name and the state. Yes. We could even add the adapter, for example. And then close it and run it. The adapter is giving me a lot of data. Let's leave that one out. So now you see all the feature flags nicely configured with the status. Let's say we want to enable a feature flag. Then we can do that by using the colon and then the name of the flag. But this one is already enabled, so we can also say, let's disable it. We do it like this, and then it's disabled. Now it's off. Cool. That's all. If you want to close it, the end of file, Ctrl D, will close the console. Now I'm trying to get back to the presentation. I would like to thank you all for listening and hope to see you in the next presentation. Thank you.